Scientists crossed a boundary in space and regretted it. There is a moment in every scientific journey when curiosity crosses a line it cannot see. For centuries, we believed the universe was something to be observed from a safe distance. We built instruments, launched machines, and sent silent messengers into the dark, convinced that space would reveal its secrets slowly, patiently, and without resistance. Every discovery reinforced the same quiet assumption. The cosmos may be vast, but it is ultimately understandable. Then came the edge. Not a wall, not a barrier you could point to on a map, but a threshold. A region where the influence of our sun fades into something older, colder, and far less familiar. It was supposed to be a transition, a simple crossing from one environment to another, a routine milestone in the long story of exploration. But something did not behave as expected. The first anomaly was almost invisible, a detail so small it could have been ignored. A fluctuation in data, a signal that did not match the equations that had guided decades of certainty. Nothing dramatic, nothing that suggested danger, just a quiet contradiction. And yet, that contradiction refused to disappear. Because in science, the most dangerous discoveries are not the loud ones. They are the ones that whisper that reality might not be what we think it is. And once that whisper is heard, it becomes impossible to unhear. What began as a mission to observe the boundary of our solar system slowly transformed into something else, something far more unsettling. Not a journey into empty space, but into a region where the universe itself seemed to hesitate. And the deeper we looked, the clearer it became. We had not just reached a boundary, we had crossed something that was never meant to be crossed, the signal that should not exist. It began with something so small that no one expected it to matter. A distant probe, drifting farther than any human creation had ever gone, continued its silent mission through the dark. It did not think, it did not question, it simply measured reality and sent it back. A mechanical witness at the edge of everything we believed we understood. And then, within the calm rhythm of its transmissions, something changed. The signal did not disappear, and it did not break. It remained stable, almost reassuring in its consistency. But inside that stability, there was a deviation, a subtle fluctuation that should not have existed, a behavior that did not match any known interaction between particles, radiation, or magnetic fields. It was not dramatic enough to trigger alarm, yet it carried a quiet contradiction that refused to align with decades of certainty. At first, it was ignored. This is how most anomalies are treated, especially in environments as complex as deep space. Instruments degrade, signals distort, and distance introduces imperfections that are difficult to predict. Scientists assumed it was noise, a minor error buried within an otherwise reliable stream of data, the kind of problem that disappears once examined closely. So they examined it. Calibration routines were repeated, comparisons were made with previous datasets, and every known source of interference was considered. For a brief moment, the explanation seemed sufficient. The anomaly was classified, understood, and set aside. Confidence was restored, and the mission continued as planned. But then the contradiction returned, not as a copy, but as a variation. The same kind of inconsistency, appearing under different conditions, embedded within new data. It was subtle, but it was persistent. And persistence is what transforms a coincidence into a problem. Because random noise does not evolve. It does not adapt its form while preserving its nature. This is where the tension begins to grow. The models that had always worked no longer provided complete answers. They were not entirely wrong, but they were no longer enough. The signal continued to arrive, calm and uninterrupted, carrying within it a pattern that could not be fully explained. It was not chaos. It was something far more unsettling. It was structured, but not understood. And then came the question that changed everything. What if the instruments were not failing? What if the data was correct, and the flaw existed in the way we interpreted reality? That possibility does not arrive easily in science, because it forces a deeper confrontation. It suggests that the universe is not behaving incorrectly. It suggests that we are the ones who do not yet understand how it behaves beyond a certain point. The myth of a predictable universe. For a long time, we believed the universe was something that could be mastered through patience and logic. Every discovery reinforced the same quiet confidence. The laws of physics were not just reliable, they were universal. Whether near Earth or at the edge of the solar system, the same principles applied. Gravity behaved the same way. Particles followed the same interactions, and space itself responded with a consistency that allowed us to predict what we had never seen. This belief was not arrogance. It was built on success. From the motion of planets to the behavior of light, from the structure of atoms to the expansion of the cosmos, every layer of reality seemed to confirm that the universe could be understood. It might be complex, but it was not unpredictable. And that distinction created a sense of stability that guided every mission we launched into the unknown. When we sent machines into deep space, we did not send them blindly. We sent them with equations, with models, with expectations shaped by decades of observation. Even in regions we had never reached, we believed we knew what we would find, not in detail, but in behavior. Space would remain consistent. It always had. This is what made the anomalies so unsettling. It was not just a strange signal, it was a contradiction of something far deeper. If the data was accurate, then the universe was not behaving in a way that matched its own established rules. Not entirely different, not chaotic, but altered just enough to create doubt. Doubt is not a weakness in science. It is a signal that something important is being overlooked. And in this case, the doubt did not come from imagination. It came from observation. The kind of observation that refuses to align with expectation, no matter how carefully it is tested. The kind that forces a question no one wants to ask. What if the predictability we trust only exists within a limited region? What if the laws we rely on are not wrong, but incomplete? It is a subtle shift in perspective, but a profound one. It suggests that everything we understand might only apply under certain conditions, within a boundary we have never fully defined. And if that boundary exists, then crossing it is not just a matter of distance. It is a transition into a different context of reality, a place where the same laws may still exist, but no longer behave in the way we expect. And that possibility changes the meaning of exploration itself. The invisible border no one truly understood. There is no sign in space that tells you are leaving one domain and entering another. No line drawn across the void, no visible boundary separating the familiar from the unknown. And yet, such a boundary exists, not as a wall, but as a region of transition, where the influence of our sun slowly gives way to the vast environment of interstellar space. For years, this boundary was treated as a simple concept, a theoretical limit where solar particles lose their dominance and the surrounding galaxy begins to take over. It was described, modeled, and mapped with confidence. A gradual shift, nothing abrupt, nothing dramatic, just a change in conditions, predictable and smooth. But theory has a way of simplifying what reality refuses to make simple. Because this boundary is not empty, it is not passive. It is a dynamic region shaped by forces that collide, interact, and push against one another. The solar wind flowing outward from our star meets the pressure of interstellar particles moving through the galaxy. Two environments, each with its own behavior, each carrying its own history, meeting at a point we once believed we understood. What we did not fully grasp is that this meeting is not neutral. It creates tension, not visible, not violent, but measurable. A subtle resistance that builds as one influence fades and another begins. And within that resistance, conditions emerge that do not exist anywhere else in our solar system. Conditions that cannot be fully replicated, only observed. When the probe approached this region, it was expected to cross it like a traveler passing through fog. A slight change in readings, a gradual adjustment, and then a continuation into a new environment. That was the assumption. That was the model. But what happened was not a smooth transition. The data began to shift in ways that did not follow a clean pattern. Instead of a clear crossing, there was hesitation. Fluctuations appeared, not random, but not fully structured either. As if the boundary itself was not fixed, but responsive. Not a line, but a zone that could stretch, compress, and react to the very presence moving through it. And this is where understanding begins to falter, because if a boundary behaves dynamically, then it is not just a passive divider. It becomes a participant in the interaction. It influences what passes through it, and perhaps more importantly, it responds to it. The crossing is no longer one-sided. It becomes a mutual event. This realization changes everything. It means we did not simply arrive at the edge of our solar system, we engaged with it. And in doing so, we may have triggered conditions that cannot be predicted from a distance. The boundary was never just a location, it was a process. And we entered it without fully understanding what that process could become when measurement stops agreeing with reality. There comes a point in every scientific investigation where the instruments stop confirming what we expect and begin to suggest something we cannot explain. It is a quiet turning point, almost invisible at first. The numbers still arrive, the systems still function, but the meaning behind the data begins to slip out of alignment. That is exactly what started to happen. The probe continued to transmit with precision. Every signal was intact, every reading carefully encoded and delivered across the immense distance. Nothing appeared broken. And yet, when scientists compared those readings with the models that had always guided them, something no longer fit. Not entirely, not in a way that could be dismissed as simple error. At first, the instinct was to question the tools. Instruments are not perfect, especially after years of exposure to radiation, temperature extremes, and the slow erosion of time. It is reasonable to assume that what you are seeing is not what is actually there. So the data was tested again, filtered, recalibrated, examined from every possible angle. But the contradiction remained. What made it more unsettling was not just the presence of inconsistency, but its persistence. The anomaly did not disappear under scrutiny. It adapted, appearing across different measurements, touching multiple aspects of the data: particle behavior, magnetic alignment, pressure gradients. Each one slightly off, each one refusing to fully match the expected patterns. This is where confidence begins to fracture, because science depends on a fundamental agreement between observation and theory. The instruments measure reality, and the models explain it. When those two elements stop aligning, one of them must be wrong. And for a long time, it is easier to believe the fault lies in the measurement. But what happens when every attempt to correct the measurement fails? The question shifts, not immediately, not comfortably, but inevitably. What if the instruments are not the problem? What if they are showing us something real, something that simply does not conform to the framework we have built to understand it? This is not a small adjustment, it is a profound disruption. It means that reality, in that region of space, is behaving in a way that cannot be fully described by the models we trust. Not because the models are useless, but because they were never designed for this environment. And that leads to a deeper realization. We did not just encounter an anomaly, we encountered a condition where our ability to measure the universe remained intact, but our ability to interpret it began to fail. And when interpretation fails, certainty dissolves. What remains is a space where observation continues, but understanding lags behind. And in that gap between what we see and what we can explain, something new begins to take shape. The silence that became inconsistent. Space was always defined by its silence, not the silence we experience on Earth, filled with subtle echoes and distant vibrations, but a deeper absence. A stillness so complete that it became a foundation for everything we believed about the cosmos. In that silence, signals stood out clearly. Patterns were easy to isolate. The background was stable, predictable, almost comforting in its emptiness. And then, that silence began to change. It did not become loud. There were no bursts, no sudden intrusions of noise. The silence remained, but it no longer behaved the same way. It started to shift, almost imperceptibly, as if the absence itself was no longer uniform. Small variations appeared in what should have been constant, subtle fluctuations where there should have been none. At first, it was dismissed as interference. At such extreme distances, even the faintest disturbance can alter perception. But this was different. The changes were not random. They appeared with a consistency that could not be easily explained, embedded within the quiet, repeating just enough to resist being ignored. This is where the discomfort deepens, because silence is supposed to be the baseline. It is the control condition against which everything else is measured. When silence itself becomes unstable, the reference point disappears. You are no longer comparing signals to a constant background. You are comparing them to something that is quietly shifting beneath your feet. The probe continued to listen, and what it found was not noise, but variation within emptiness, a kind of structured absence where the lack of activity carried its own form of behavior. It was as if space, in that region, was not entirely passive, as if the void itself had properties that only revealed themselves once you entered it. Scientists tried to anchor the data to familiar explanations, known sources of cosmic radiation, distant electromagnetic interference, subtle distortions caused by the probe's own systems. But none of these fully accounted for what was being observed. The silence remained inconsistent, and the more it was studied, the more it resisted simplification. And this is where a new question begins to emerge. If silence is not truly empty, then what is it? What are we actually observing when we describe the void as nothing? Because if that nothing can change, if it can carry patterns, if it can behave in ways that differ from expectation, then it is not nothing at all. It is something we have never fully understood. And that realization carries a quiet weight, because it suggests that the universe is not only defined by what is present, but also by the structure of what appears to be absent. And once that structure begins to shift, even slightly, it changes the way every signal is interpreted. The silence did not disappear. It became uncertain. And in that uncertainty, the boundary we thought we crossed began to feel less like a location and more like a transformation. The first signs that space pushes back. Up to that point, space had always behaved like a stage, vast, indifferent, and passive. It allowed movement, it allowed observation, but it never resisted. Everything we sent into it traveled according to expectation, guided by forces we could calculate, drifting through a medium that offered no opposition beyond what we already understood. Then, something changed. The data began to suggest that movement through this region was no longer neutral. Not in a dramatic way, not as a force you could feel, but in subtle deviations that accumulated over time. Particle densities did not align with predictions. Pressure readings hinted at a tension that should not have been there. Even the distribution of energy began to show irregularities that implied something more than simple transition. At first, these signs were treated as extensions of the boundary. After all, the edge of the solar influence was expected to be complex. Interactions between solar wind and interstellar particles could create turbulence, distortions, temporary imbalances. But what the probe observed did not behave like turbulence. It behaved with a strange consistency, as if the environment itself was responding rather than simply reacting. This is where the idea becomes difficult to ignore, because reaction implies passivity. It implies that something external is causing a disturbance. But response suggests something different. It suggests that the environment has its own state, its own behavior, and that this behavior can shift when something enters it. The difference is subtle, but it changes the entire interpretation of what is happening. The probe continued forward, and the irregularities did not fade. They adjusted. As if the deeper it moved, the more the surrounding conditions reorganized themselves, not in a coordinated or intentional way, but in a manner that could not be reduced to random fluctuation. The patterns were too consistent to be dismissed, yet too complex to be explained by existing models. This is the moment when the narrative of exploration begins to shift. We were no longer just observing a distant environment. We were moving through something that did not remain entirely unaffected by our presence. The data did not prove interaction in a direct sense, but it suggested a form of influence, a mutual relationship between the observer and the observed that had never been accounted for at this scale. And that realization introduces a new kind of tension. Because if space can exhibit resistance, even in the most subtle way, then it is not simply a background. It becomes a medium with properties that extend beyond what we have measured within the safety of our solar system. A medium that may behave differently when disturbed, when crossed, when entered without full understanding. The signs were not dramatic. There were no sudden shifts, no unmistakable indicators of danger. Just a steady accumulation of deviations that pointed in the same direction. Something in that region did not behave as a passive void. It behaved as if it had a state. And once that idea takes hold, it becomes impossible to return to the assumption that space is simply empty. Because if it can push back, even slightly, then crossing it is not just a matter of distance. It is a form of engagement. The growing divide among scientists. At first, the anomaly belonged to the data. A small inconsistency, confined to measurements, something to be corrected, explained, and eventually forgotten. But as the signals continued, as the contradictions repeated across different parameters, the anomaly began to move beyond the instruments. It entered the conversations. And that is where things started to change. Because science is not just built on data, it is built on agreement, on shared frameworks that allow thousands of minds to interpret reality in a consistent way. When those frameworks hold, progress feels stable. But when they begin to fracture, even slightly, the divide is not immediate. It emerges quietly in the form of different interpretations. Some scientists remained grounded in certainty. For them, the explanation was still within reach. The anomaly had to be an artifact of measurement, an unknown variable, a gap in calibration, something technical, something solvable. Because the alternative, That the universe itself was behaving outside established expectations required a shift too large to accept without resistance. Others began to see it differently, not as a failure of instruments, but as a limitation of models. They did not claim that the laws of physics were broken. They questioned whether those laws were being applied in a context they were never meant to fully describe. The boundary in this view was not just a location. It was a condition where known rules might begin to express themselves in unfamiliar ways. This difference in perspective created tension, not conflict in the dramatic sense, but a divergence in approach. The same data, the same signals, leading to different conclusions about what was truly happening. One side searched for errors within the system. The other searched for meaning beyond it. Both grounded in logic, both driven by evidence, yet moving in different directions. And as more data arrived, the divide did not disappear. It deepened. Because each new anomaly could be interpreted in two ways, as confirmation of a hidden technical issue or as reinforcement of a pattern that suggested something more fundamental. The longer the signal persisted, the harder it became to maintain a single unified explanation. This is where uncertainty becomes collective. It is no longer confined to individual interpretation. It spreads across the field, influencing how questions are asked, how models are tested, how conclusions are framed. The search for answers continues, but the path forward is no longer clear. It branches, splits, and forces choices that cannot be easily reversed. And beneath all of this, a quiet realization begins to take shape. The anomaly is not just challenging the data, it is challenging the agreement. And once agreement begins to fracture, even slightly, the process of understanding slows down. Not because the truth is unreachable, but because the lens through which we search for it is no longer singular. The universe has not changed in that moment, but our relationship with it has, patterns without explanation. At first, the anomalies were tolerated because they were isolated. A fluctuation here, a deviation there, each one small enough to be explained away, or at least contained within the uncertainty of measurement. But over time, something more unsettling began to emerge. The anomalies started to repeat. Not perfectly, not in a way that could be easily mapped or predicted, but with enough consistency to suggest that they were not random. They appeared under different conditions, across different readings, yet carried a familiar structure, a kind of signature that could not be ignored once it was recognized. This is the moment when uncertainty transforms into tension. Because randomness is comfortable. It means there is no underlying pattern, no hidden mechanism waiting to be understood. But repetition changes that. It implies structure, and structure demands explanation. When something repeats without a clear cause, it creates a gap between observation and understanding that cannot remain empty for long. Scientists began to track these patterns more closely, not just as isolated events, but as part of a larger behavior. The data was analyzed across time, across different variables, searching for correlations that might reveal a hidden rule. But every attempt to define that rule led to the same outcome. The pattern was real, the explanation was not. This is where the discomfort deepens in a way that is difficult to express, because the human mind is built to resolve patterns, to find meaning, to connect cause and effect, to reduce complexity into something manageable. When that process fails, when a pattern exists without a framework to contain it, it creates a kind of cognitive tension that does not easily fade. The probe continued its journey, and the patterns did not disappear. They evolved, subtle shifts, slight variations, but always carrying the same underlying inconsistency. Enough to suggest that something stable existed beneath the surface, something that followed its own logic, even if that logic remained hidden. And this is where the narrative begins to shift again, because the question is no longer whether the anomalies are real. That has already been established. The question becomes something far more difficult. Why do they repeat? And what determines their behavior? What is the mechanism that produces consistency without clarity? The absence of an answer becomes more unsettling than the anomaly itself, because an unexplained event can be ignored. A repeated pattern cannot. It demands attention, it demands interpretation, and when that interpretation fails, it leaves behind a space filled not with knowledge, but with unresolved possibility. And in that space, a new idea begins to form. Not yet a theory, not even a hypothesis, just a realization that grows stronger with each repetition, that what we are observing may not be random and may not be fully describable within the system we currently use to understand the universe. The pattern does not reveal its meaning, but it refuses to disappear, and that refusal changes everything. The hypothesis. No one wanted to say out loud. There is a moment in every scientific pursuit when the data begins to point toward a possibility that no one is ready to accept. Not because it is impossible, but because it forces a shift so deep that it changes the meaning of everything that came before. That moment does not arrive with certainty. It arrives as hesitation. The patterns had already established themselves. The anomalies were no longer isolated, no longer dismissible. They repeated with enough consistency to demand explanation, yet resisted every framework designed to contain them. The data was clear, but its meaning remained just out of reach. And in that gap, a question began to take shape. What if the boundary we crossed was not just a region of space, but a change in the conditions of observation itself? This idea did not emerge as a conclusion. It appeared slowly, cautiously, almost reluctantly. Because it does not suggest that something external is acting upon the probe. It suggests something more subtle, that the act of entering this region alters how reality is measured, how signals behave, how interactions are expressed. Not a discovery, but an interaction. For decades, observation has been treated as a passive act. We look, we measure, we record, and the universe reveals itself without being affected by our presence. This assumption works remarkably well within the environments we have studied. But beyond that boundary, the data begins to hint at something different. The measurements remain precise. The instruments continue to function. But the relationship between what is measured and what is expected begins to shift, as if the context itself has changed, altering the way known laws manifest rather than breaking them entirely. This is where the discomfort becomes difficult to ignore, because if observation is not entirely passive, then exploration carries consequences beyond what we have considered. Not dramatic consequences, not immediate or destructive, but subtle changes that influence the behavior of the environment being studied. A mutual presence, where the observer and the observed are no longer completely separate. This hypothesis does not claim certainty. It does not offer a clear mechanism or a definitive explanation. It exists as a possibility, one that emerges naturally from the data but resists being fully articulated. And that is precisely why it is so difficult to accept. Because it challenges a fundamental assumption, that the universe can be observed without being changed by the act of observation. If that assumption begins to fail, even in a limited context, then the implications extend far beyond a single anomaly. It suggests that there are regions of reality where our presence, even through a distant probe, becomes part of the system being measured. Not dominant, not controlling, but involved in a way we have never fully accounted for. And once that possibility enters the conversation, it cannot be easily removed. Because every new piece of data must now be viewed through a different lens, not just as information about a distant environment, but as part of an interaction that includes the very act of measuring it. The hypothesis is not spoken loudly. It does not need to be. It lingers just beneath the surface of the discussion, shaping the questions that follow. And in doing so, it transforms the anomaly from a problem to be solved into something far more complex. A boundary that was not only crossed, but engaged. The moment we realized we are not just observing, there is a quiet shift that happens when a question stops being about the universe and starts being about us. For a long time, we believed that exploration was a one-sided act. We built instruments, sent them into the unknown, and waited for the universe to reveal itself. The observer and the observed were separate, cleanly divided. One measured, the other existed. That separation gave us confidence. It made the cosmos feel stable, even when it was vast. But the data no longer supported that simplicity. The patterns, the inconsistencies, the subtle responses within the environment all pointed toward a deeper realization. Not immediate, not obvious, but impossible to ignore once seen. The act of observing, especially at this boundary, might not be passive. It might be part of the interaction itself. The probe did not change its mission. It continued to transmit, to measure, to move forward without awareness. Yet the environment around it did not remain entirely indifferent. Conditions shifted in ways that could not be fully explained by external forces alone, as if the presence of the probe, the act of entering and measuring, was part of what shaped the data it received. This is not a dramatic transformation. There are no clear signs of cause and effect, no direct evidence that observation creates change in a measurable, isolated way. What exists is something more subtle, a growing alignment between movement, measurement, and variation, enough to suggest that the boundary is not just a place where conditions differ, but a region where interaction becomes unavoidable. And that changes the meaning of exploration. Because if observation becomes interaction, then every measurement carries a trace of influence. Not large enough to dominate, not precise enough to control, but present, embedded within the data, inseparable from the environment it describes. The universe is no longer a distant object. It becomes a system in which we participate, even from unimaginable distances. This realization does not invalidate what we know. It reframes it. The laws of physics remain. The models continue to function. But their application becomes contextual, dependent on where we are, how we measure, and what conditions surround the act of observation. The boundary does not break the rules. It reveals that the rules may express themselves differently when the context changes. And in that shift, something becomes clear. We are not standing outside the universe, looking in. We are inside it, moving through it, influencing and being influenced in ways we are only beginning to understand. Even at the farthest edge we have reached, even through a silent machine drifting in the dark, that connection remains. The moment we recognized this was not marked by certainty. It was marked by perspective, a subtle but irreversible change in how we see our place in the cosmos. No longer as distant observers, but as participants in a reality that does not remain untouched by our presence. And once that perspective takes hold, the boundary we crossed becomes more than a location. It becomes a mirror. We crossed the boundary, and the universe did not remain the same. There is no moment in the data where everything suddenly becomes clear. No single transmission that explains what happened, no final reading that resolves the contradictions. The signal continues, the patterns persist, and the boundary remains exactly where it always was. From a distance, nothing has changed. The probe moves forward, the universe expands, and the silence of space stretches on without interruption. And yet, everything is different, because what changed was not the universe itself, but the way we understand it. The anomalies did not rewrite the laws of physics, but they exposed the limits of how those laws are applied. They revealed that what we once believed to be universal may, in fact, be contextual, dependent on where you are, how you observe, and what unseen conditions shape the environment around you. This realization does not arrive as a conclusion. It settles slowly, like a weight that cannot be ignored. We crossed a boundary expecting to find answers, to extend our knowledge into a new region of space. Instead, we found questions that reached back toward us. Questions about the nature of observation, the behavior of the void, and the possibility that reality itself is more sensitive to context than we ever imagined. The signal that should not exist still exists. The patterns without explanation still repeat. The silence that once defined space now carries a subtle uncertainty that cannot be removed. These are not temporary anomalies waiting to be resolved. They are part of a deeper layer of reality that we have only just begun to encounter. And this is where the story truly ends. Not with certainty, but with awareness. Because the greatest discovery was never something waiting beyond the boundary. It was the realization that crossing that boundary changed the way the universe reveals itself to us. That our presence, even at the farthest edge, is not entirely separate from what we observe. We did not find something watching us. We found a universe that does not remain completely indifferent when we arrive. And once that truth settles in, even quietly, it cannot be undone.